In this video, we're going to introduce the composition of functions. Let's take two functions f and g, and a regular function is like a machine. But when you put two functions together, f and g, then you have sort of an assembly line. You have f here, you have g here, or you have g and then f. Okay, so let us represent the function f by this shape here, triangle, and then g by a square or a rectangle. So when you compose f and g, f compose g of x is f of g of x. G compose f of x is g of f of x. Okay, so for example, if you're doing f compose g, that means you're doing f of g of x, and g of x is the square. So what you do is you take the square and you put it inside the function f for x. But if you're doing g of f of x, g is the main function, so you take f of x, which is the triangle, and you put it in g. So you can put g in f or f in g. And that's what the composition of functions is. In general, f of g is not the same as g of f. And the way to pronounce it is f compose g for f of g, g compose f for g of f. Before we start and before we do any examples, let us keep in mind that f and g both have domains. It could be all real numbers or something else. For example, if one of them is this function here, then for this function here, x cannot equal 2 because it makes the denominator 0. So make sure if you're calculating f of g of 2 or g of f of 2, it doesn't exist. So we need to respect the domain of both functions. Let's do some examples. In this example, f of x is 3x minus 1, and here's g of x, x squared. We're looking for both f of g of x and g of f of x. So f of g of x is f of g of x. So what you do is you take g of x, which is this, and you put it in place of x in the function f. So the function f is 3 times bracket minus 1, 3x minus 1. You take x squared and you put it in there in place of x. We'll simplify it in a minute. For g of f of x, the main function is g. So here's g. G is something squared. What do you put inside the parentheses? You put the other function, 3x minus 1 squared, and we'll simplify that. So for the first one, it'll be 3x squared minus 1. For this one, we're foiling, so it'll be 9x squared minus 3x plus 1, which is 9x squared minus 6x plus 1. Let's go over this again. When you're doing f of g, you take g and you put it in f as x. When you're doing g of f, you take f and you put it into g. So you take this whole thing here and you put it in here for x. We'll do another example. Example 202. F of x equals x cubed and g of x equals 4x. So for f of g, the main function is f, which is something cubed. And what goes in here is the other function, which is 4x. So you put 4x here. 4x all cubed. We'll simplify it in a minute. For g of f of x, the main function is g. G is 4 times something, 4 times bracket. What goes in the bracket? F of x. So you put x cubed here. For the second one, it's just 4x cubed. But here the 4 is also cubed. So it'll be 4 cubed, which is 64 x cubed. And for example 203, f of x is 5x, g of x is x to the 4th minus 3. So f of g of x, the main function is f. So it'll be 5 times something. And that something is a bracket. What goes in the bracket is g of x, which is x to the 4th minus 3. We'll simplify it in a minute. For g of f, the main function is g, so it'll be something to the power 4th minus 3. Okay, so it'll be, for this one, minus 3. So for the first one, we distribute the 5. 5 x to the 4th minus 5 times 3, which is 15. And then this one here will be 625 x to the 4th minus 3. And note that f of g is not equal to g of f. Our next topic is the concept of inverse of a function. In order for a function to have an inverse, okay, take this function for example. F of x equals 3x minus 1, that's y. If you take any number like 3, f of x equals 3 times 3 minus 1, which is 8. So for every x value, there's only one single value of y that corresponds to it, that's paired with it. And for every y value, there's only one value of x that's paired with it. This type of function has an inverse. Take this example here. G of x equals x squared. G of x equals x squared. When x equals 3, g of x is 9. But when x equals negative 3, g of x is negative 3 squared, which is also 9. So both 3 and minus 3 are paired with 9. So this function here does not have an inverse. Okay, so for this function, every value of x is only paired with one value of y. It's called a one-to-one function. For this one here, that's not the case. So this function has an inverse. This one doesn't, but we can do something to it to make it have an inverse. Let's do some examples. Okay, well, before examples, the symbol for the inverse is f with a superscript -1. When you compose a function with its inverse, the composition should always give you x. That's just one way to check. When you compose the inverse into the function, that also gives you x. And here's how you find the inverse. 2 steps only. After you write the function as y equals f of x, switch the letters x and y and then solve for y. That's it. Switch the letters x and y and then solve for y. For example, in this function here, find the inverse of this function. F of x equals 4x minus 1. That means y equals 4x minus 1. Switch the letters x equals 4, y minus 1, and then solve for y. Okay, to solve for y, add 1 to both sides. So x plus 1 equals 4y. Divide by 4. Y equals x plus 1 over 4. And then you can write it like this. Inverse function of x equals x plus 1 over 4. We could check if this is actually an inverse by doing this. By composing one function into the other one. Let us check. Okay. F compose f minus 1. The main function is f. So that's 4x minus 1. But x becomes the inverse, which was x plus 1 over 4. So 4 cancels. That leaves you with x plus 1 minus 1, which is x. You don't have to check this, but we'll check it. Inverse of f, compose f. The main function is the inverse. Okay, here's the inverse. The inverse was x plus 1 over 4. So you do something plus 1 over 4. And that something is the first function, which is 4x plus 1. So 4x plus 1 minus 1 over 4. The plus 1 minus 1 cancels. 4x over 4 is just x. Let's do another example. F of x equals x squared, but this time we have a condition. X is greater than or equal to 0. So we'll write it as y equals x squared. Switch the letters x and y. X equals y squared. Solve for y. So y equals square root of x. Okay, so the inverse is square root of x. Okay, let us check. Okay, if you're doing f of g of x, or f of f minus 1 of x, the main function is f, which is x squared. So it's something squared. What do we put inside here? The inverse. The inverse was root x. Okay, root x all squared is just x. Let's do g of f of x, or f minus 1 of f of x. The inverse was square root of x, so it will be square root of f of x, and f of x was x squared. Okay, this is x because x is positive. So both ways